Okay, so there was a request that I said I'd take 3 to 4 problems on your assignment. And the first question that came up was problem number 2 and 3. Was that question 3 and question 2? So part of what makes this unit challenging sometimes for people, I think, I don't know for sure, but I think, is that you have to remember both how to take derivatives and antiderivatives. So that's probably the biggest challenge as people move on, they take Calculus 2. They're like, well, I did fine in Calculus 1. Why am I not ready for Calculus 2? Because you don't remember how to take derivatives anymore. It's like gone. And you don't remember how to take antiderivatives. And the first day you show up on Calculus 2, they expect you to remember, you know how to do 3 things. Take any limit, take any antiderivative, and take any derivative. Those 3 things. So the idea is that we want to show by differentiation that the derivative of this is this. And so I need to take this derivative. So x sine of x plus cosine of x plus c. I'm going to take that derivative and I should come up with that thing right there. Let's do the easy part. What's the derivative of c? What's the derivative of cosine? Negative sine. Those are easy, right? This part requires that I use what rule? The product rule. The product rule says the derivative of x is 1 times sine of x plus x times the derivative of sine is cosine. Notice we said the derivative of cosine was negative sine, and the derivative of a constant is 0. So sine of x and negative sine of x do go away, and I'm left with x cosine of x. Nope. I just need to see your work that you did in fact do that. Every once in a while I'll get people, they'll get to the test, they'll be like, I don't know what I'm doing. And so here's what they will do instead. They will just, they'll just do this. They'll write x cosine of x because they know what the answer is supposed to be. You see what I'm saying? For that I award you 0 points. And then you get frustrated, you say, but that's the answer. No, it says verify by differentiation. This is more of a proof. So if you don't like it, I'm sorry, you're wrong. I can't find a single math person who would agree with you. So, all right. So number 3, this is a common one, number 3, that people get frustrated with. I want to take the derivative of this, and it should produce that right there. Okay? So I'll write it out. 1/4 x e to the 4x minus 1/16 e to the 4x plus c. I'm going to take that derivative. So what rule do you have to use here? Product. So what is the derivative of 1/4 x? 1/4. You have e to the 4x. I will do plus 1/4 x. Now I need the derivative of e to the 4x. Does anybody know what the derivative of e to the 4x is? Why?
Because the derivative of e of x, well, e to the x, e to the x, but you have to take the 4 because if you did the e, yeah, that.
Chain rule. When you take the derivative of e to the 4x, you use the chain rule. E to the u and 4x. The derivative of e to the u is e to the u, and the derivative of 4x is 4. So you can see that the derivative of e to the 4x is 4e to the 4x. So usually what this unit does is it helps us remember some of the differentiation rules that we've forgotten and hopefully refine them. So I just took care of this guy right here, okay? That guy right there. Does anybody know what rule I have to use there? The chain rule. So I'll leave the minus sign, and I have 1/16 e to the u. And on the inside, I have 4x. What's the derivative of 1/16 e to the u? 1/16 e to the u. And the derivative of 4x? 4. what will you get when you multiply those together? 1/4 e to the 4x. Good. I just took care of that derivative. And now I need the derivative of c, which is 0. What do you notice about what I have here? Those two cancel. 1/4 times 4 is, and so I get x e to the 4x, which is exactly what I should have. Sir?
How'd you get that? I know how I got the 1/4. I know how you probably got the 1/4 at. Oh yeah, you probably. Okay, you had to do the
Product rule?
product rule.
Yep. Yep. Okay. 2 more? Yeah. 5? Ooh, wow. Ouch. You guys want to tackle those, huh? How about I do one and you guys do the other? Is that fair enough? I think that 5 is more challenging. So I'll do 5 and you do 6. How's that? Okay. So part of the preparation is that we are experts in algebra. Yes, no? Yeah, we still continue to make many mistakes in algebra. In fact, we could argue that the majority of mistakes that we make are not actually calculus mistakes a lot of time, but they are algebra mistakes. So let's try to find this derivative right here. Good luck on the psych test later today. So the derivative of c is 0. How am I going to find this derivative? The quotient rule. So we're in for the long haul here. Okay, this is going to be a fair amount of work. The quotient rule says I take the derivative of the top, which is 1, times the bottom as is, so a squared root of a squared minus x squared. I'm just going to go ahead and leave that 1 off there, just because obviously 1 times anything is itself. And then is it a minus or a plus? Minus the top times what? The derivative of the bottom. You don't need to use the product rule because a squared is simply a constant. Okay, so this is the variable, your x is the variable, so we're just going to use the chain rule on the bottom. Okay, we're just going to use the chain rule. So I'll set up the chain rule right here in this space I have, and I'm going to write it as a squared times u to the 1/2. What goes on the inside? A squared minus x squared. A is just a constant. Anytime you see something different than the variable that you're integrating, you can just treat it as a number. It just comes along for the ride. So for example, if you had 9x squared, the derivative is 18x, right? So the 9 just continues to multiply. So what's the derivative of u to the 1/2? 1 over 2 roots of u, but because you have the a squared, you're going to have an a squared on top, okay? What's the derivative of a squared minus x squared? Negative 2x. I multiply these, and what happens? The 2's go away, and I get a negative a squared x over the square root of a squared minus x squared. You see it? Because I have the negative x, so negative x, I have the a squared on the top, and on the bottom I have that guy. Okay, all over. Then what do I do to the bottom? Yeah, the bottom squared, so I will have an a to the fourth, and then I have the quantity a squared minus x squared when I square that out. We okay with that? Okay, good job. That's the most challenging piece, is to get the first step set up correctly. Notice now we have a complex fraction. That's pretty tough right there. We'll make good use of it. I have a squared roots of a squared minus x squared over 1. Is it going to be a plus or a minus? Plus what? A squared x squared over very good. And that is all over a to the fourth times a squared minus x squared. This x times x squared.
Hold on, can you scroll off for a moment? So, is the a squared just completely nullified in the chain rule?
It's just a constant, it's a multiplier. It just comes along for the ride. Kind of like if you have 3x squared, you're going to take the derivative, it's 6x squared. I mean, it's not like the 3 disappeared, it's being multiplied by the 2. The a squared is still multiplying that piece.
So why you cross out the a?
It's not, I had a 1 there, I just wrote it over. Patty? So I squared the bottom. If you square that, you get a to the fourth. If you square that, the square goes away.
Oh wait, now I can't really. Well, negative. So for the right side where you had negative, like a squared minus x squared, you just got rid of the a squared. Like go scroll back up for a moment. When you have on the right side, you have a squared minus x squared.
Yes. So the derivative of a constant is 0.
So a is constant is never.
Yeah, if you consider these two situations, if I have 9x squared and if I have 9 minus x squared, the derivative of this would be 18x. The 9 is still multiplying, but the derivative of this constant is 0 and then negative 2x. It is a constant. Okay, so I have this big piece. What do you have to do in order to simplify your complex fractions? Common denominators. The rest of this is all algebra. There's 0 calculus involved. So what is the common denominator? Root of a squared minus x squared. Okay. Well, we can make this pretty simple now, okay? We have a squared times what? A squared minus x squared. So that's what this becomes on top. Plus what? A squared x squared over what? Yep, and for purposes that we're going to see later on, I'm going to write it as a squared minus x squared raised to the 1/2 power. Over what? A to the fourth times a squared minus x squared all over 1, right? We are close. You're almost there. I know it doesn't look nice, but it is ready to work itself out. Let's simplify this numerator right here. What do you get in top? A to the fourth minus a squared x squared plus a squared x squared over and can everybody see if I were to multiply by the reciprocal, then this thing just joins down in the denominator? So I have times a to the fourth times a squared minus x squared to the 1. What? What happens on the numerator? A squareds, x squareds are gone. What are you left with in the top? A to the fourth. What do you notice about the bottom? It's also an a to the fourth in the bottom. So we're left with 1 in the top. What do you notice about these two things? They're the same base. And if you have same bases, what do you do the exponents when you multiply? Add. What's a half plus 1? 3 halves. So a squared minus x squared to the 3 halves power. What is a different way you can write 3 halves power? Is that what I have up above? It sure is. Isn't that pretty? I don't want to do anything else on the front page. Does somebody have a question on the rest?
Wait, am I going to delete all of that?
Yeah.
Yeah, I didn't Mr. Gant, what's one that you... We can do number 28.
28? I got a bid for 28. I got a bid for 27.
No.
27? Just regular 7. Okay. Let's try 28, and then for Ella's sake, I will do problem 7. Is 28 a definite integral or an indefinite integral? It's a definite integral. If you have bounds, that makes it definite. That means you are producing a value, a singular value. Okay? So, how I start this off is I take the antiderivative of secant tangent. What is it that you take the derivative of to get secant tangent? Secant. Is it fair to say that some of you remember your derivatives and some of you don't? So here's what I could do for you. Is number one, I could tell you that you will receive no notes like that on the test. But what I can also tell you is that I will give to you this. So to help you in your work, here are all the derivatives that you've had over the course of this year. They're all sitting right there. So if you want a nice, helpful sheet in which you can kind of help, kind of talk to each other and say, hey, do you know this derivative? Do you know that one? There's the list right there. You should have these memorized, yes. Okay? You will not be given them, without a doubt. You need to have these. If you step into Calculus 2 and you don't know that, the teacher will ask you to leave and try again. Okay? Yep. Okay. Now, here's the other piece. What you want to be able to commit to memory eventually are these integrals. We have all these integrals now on the right-hand side. That's where we're starting to work. So, the antiderivative of secant tangent is grand old secant. So I need to evaluate secant at pi over 3 and at pi over 4. Because I am really good at trigonometry because I had a great junior year, I'm going to draw my angles. What is pi over 3? 60. What's the terminal point for 60? 1/2 at root of 3 over 2. Good. Pi over 4 is 45 degrees. What is that terminal point? Root of 2 over 2, root of 2 over 2. So, secant is the same as what? 1 over cosine. So, I have 1 over cosine of theta evaluated at pi over 3 and at pi over 4. What is the cosine of pi over 3? 1/2. I do 1 over 1/2, which is dos, Spanish for 2. What is the cosine of pi over 4? Root of 2 over 2, and so you do 1 over that, so minus 1 over the root of 2 over 2. So we've almost got an answer here. We just need to do 1 over the root of 2 over 2. Doesn't that just mean you take the reciprocal? We have 2 minus 2 over the root of 2. Can I leave that? Multiply top and bottom by? Root of 2 on top, root of 2 on bottom. You get 2 minus 2 roots of 2 over 2. It's a lot of 2's. Cancel off the 2's, you get 2 minus the root of 2. For Ella's sake, we will go back to number 7. No, let's do it. Is this a definite integral or an indefinite integral? It is an indefinite integral. Yep. And so what we do for an indefinite integral that does not have bounds is we find an antiderivative, which is going to be x to 3/4 divided by 3/4 or multiplied by 4/3. And then we put a plus c. Why do we put a plus c?
Because we don't know if this constant would have the thingy of the derivative of 0.
Very good. Yep. Yeah, so the idea is that, so if we have, say, for example, 3x squared. What's the antiderivative of 3x squared? X to the third? Because if you take the derivative of that, you get that, right? But couldn't it also be x to the third minus 10? Like, doesn't that also give you that one? So we just put plus c, so that could be any constant at all. Now, we're going to use that constant later on. But okay. All right. You guys can have the rest of the time to work. I was going to cover the next lesson, but we don't have time, and looks like a lot of you are studying for your psychology stuff anyway, so does it work for you tomorrow if I cover a lesson? Okay. How about Wednesday? Can we do Wednesday? Maybe Thursday? Does it work in your schedule? We'll just send out a Google form, and you can let me know when it works next cover a lesson, and we'll do it.